Deep under a national park in the Australian Alps, engineers are boring 27 kilometres of tunnel through some of the hardest, most unpredictable rock on the continent to build a battery. Not a chemical one. A mountain-sized machine that stores electricity as water, pumped uphill when power is cheap and released downhill the instant the grid needs it. This is Snowy 2.0, and it has become one of the most expensive lessons in tunneling through unpredictable rock that Australia has ever paid for. Solar and wind are cheap, but they're not obedient. They generate power when the sun shines and the wind blows, not necessarily when a country needs electricity most. Somewhere has to store the surplus and release it on demand, at a scale far beyond what chemical batteries can do economically for an entire national grid. Australia's answer, on paper, is elegant. Use two existing mountain reservoirs at different elevations, already part of the historic Snowy Mountains scheme, and connect them with a new underground tunnel and power station. When there's excess solar or wind power, pump water from the lower reservoir up to the higher one. When the grid needs power, let that water fall back down through turbines. The mountain itself becomes the battery. Snowy 2.0 is designed to deliver 2.2 gigawatts of capacity and about 350 gigawatt-hours of storage to Australia's national electricity market. To build it, crews are boring 27 kilometres of tunnel through Kosciuszko National Park and constructing an entirely new underground power station carved out of solid rock. The star of the build is Florence, a colossal tunnel boring machine named after Florence Violet Mackenzie, Australia's first female electrical engineer, which launched in March 2022 to dig the 16-kilometre headrace tunnel connecting the underground power station to the upper Tantangara reservoir. Once complete, the system will run in reverse depending on the grid's needs. Pump mode stores energy by pushing water uphill. Generation mode releases it back down through turbines in the new underground powerhouse, in minutes, not hours. The honest number first. Snowy 2.0 was announced in 2017 at an estimated cost of around $2 billion. By 2023, that estimate had been formally reset to $12 billion. As of March 2026, actual expenditure stood at $11.1 billion. And a June 2026 government audit flagged that a further cost reassessment is likely to push the total even higher, with some independent 2026 estimates of the project's total economic cost running from roughly $20 billion to more than $42 billion. Auditors have said they can no longer reliably predict when the project will actually finish. The headline failure was mechanical and very literal. In May 2024, the Florence tunnel boring machine got physically stuck. A steering error sent it into hard rock at too sharp an angle, wedging part of its cutting head. The same machine had earlier struggled through rock that was, at other points, too soft to hold its shape. It took until July 2024, using ultra-high-pressure water jetting to cut the machine free before Florence could move again. Multiply that kind of surprise by 27 kilometres of tunnel through terrain nobody has drilled through before, and the project's cost and schedule uncertainty stop looking like mismanagement and start looking like the honest price of building something. This ambitious underground, in rock, this unpredictable. As of 2026, Snowy 2.0 remains under construction, years behind its original schedule and many billions over its original budget, with the tunneling program still working through the geological surprises that have defined the project. It is also still the most concrete, largest-scale proof under construction anywhere that a mountain range can double as a multi-day grid battery, assuming Australia is willing to keep paying and waiting for the machine that's boring it out one contested metre at a time.